This video is part of the lecture for multivariable calculus, and I'm going to talk about chain rule for several variable function. So let me start. First, let me give you a recall of chain rule in one variable calculus. So we say that if we want to differentiate a composite function, we use chain rule. How? Let's look at the function y equals to, for example, sine of x squared. So as you see, y is a function of x, but I can say that I have a function u in between, okay, and say y is a function of u and u is a function of x. Okay, so y is equal to sine of u, and then u is equal to x squared. Now if I want to take derivative of that, I would write dy dx as dy du, you see, dy du times du dx. Okay, and then I say, so dy du would be derivative of sine is just cosine of u, times derivative of u with respect to x would be just 2x. Now let me replace u with x squared, and then you see that I have derivative of y with respect to x. Now let's say that I have a function w as a function of x and y, but x is a function of t and y is a function of t. Okay, so I have this chart right now. We call it tree. We say that w is a function of x and y, and then x is a function of t, y is a function of t. So basically w is directly a function of t. Well, I can say like this. I can say that w is f of x is a function of t, and then y is also y of t. As you see, at the end of the day, w is a function of t. Okay, now how can I get derivative of w with respect to t? How can I find the w dt? Well, I say that since w is a function of two variables, I have partials, and then since x is just a function of t, I have d in here, y is a function of t, I also have d in here. So I can go along this path to go to t, and so I get what? I get partial w, partial x, and then dx dt, or I can follow this path in here and go to d, and then say partial of w, partial y, and then dy dt. That's how we define the chain rule. Okay, let's look at one example. If w is x squared y plus y squared, where x is equal to t squared and y equals to sine of t, what is dw dt? Well, I can use chain rule and say chain rule, and I'm gonna say that dw dt is, I highly recommend that you graph this tree whenever you want to solve examples of the chain rule. It's very helpful. So I can go along this path, or I can go along this path. since w is a function of just two variables, I have partials in here. X is a function of just one variable, so that's why I get d. So it will be partial w, partial x, dx dt, or I can find partial of w with respect to y, dy dt. Okay, so w with respect to x, just 2xy, dx dt, 2t, plus partial of w with respect to y, so x would be a constant, so x squared plus 2y, and then derivative of y with respect to t is cosine of t. Okay, and now let me write everything in terms of t, and then I have a 2t in here plus t to the 4 plus 2 sine t times cosine t. Another way to solve this question is to basically substitute. So I'm gonna substitute, and then I say, okay, w is x squared y plus y squared. So I get t to the 4th sine t plus sine square of t. So now you see that everything is in terms of t, so dw dt would be, I need to use product rule in here, be 4t cubed sine t plus t to the 4 cosine t plus 2 sine t cosine t. Okay, if you simplify that, you will get this for sure. Okay, so that was about this situation, that w is a function of x and y, and then x and y, they are just a function of just one variable. Now we have another situation where w is a function of two variables, and x is a function of two variables, u and v, and y is a function of two variables, u and v. Okay, so what is the situation here? The situation here is like that. W is a function of x and y, x is a function of u and v, y is a function of u and v. That's why when I want to calculate the derivative, I have partials in here, I have partials in here. Okay, and as you see that I have w equals to f of x of u and v, and then y of u and v. Okay, so w is any case is a function of u and v. Okay, so now let me calculate. I can say w with respect to u. Okay, with respect to u, okay, I can go along this path in here. Let me wait, I can go along this path in here, go to u. Actually, this is not a good color, let me make it like this. Or I can go along this path in here to go to u. Okay, so I can write dw du as what? It would be dw du times, I'm sorry, dw dx, I'm writing this branch in here, this dx, and then partial of x, partial u, or I can go along this path in here. Let me make this one purple, and I'm picking this, and I'm gonna write dw dy times dy du. The same is true for taking derivative of w with respect to the other variable v. Okay, so the w dv would be partial of w with respect to x, derivative of x with respect to v, plus partial of w with respect to y, derivative of y with respect to v. Okay, let's look at one example to see how it works. Example, let w to be x cubed y plus y to the fourth x, where x is u squared plus v squared and y is equal to 2uv. Okay, so looking at the branch, I'm gonna find partial w partial u. Okay, so with respect to u, I can go along this path in here and I write dw dx du, or partial of w with respect to y dy du. Okay, partial of w with respect to x, y would be a constant, so 3x squared y plus y to the fourth. Partial of w with partial of x with respect to u, it just be 2u, plus partial of w with respect to y, it's x cubed plus 4y cubed x. Partial of y with respect to u would be 2v. Okay, now I can replace all the x and all the y's in here by the given formulas for x and y. Now the question is, how can I find the second derivative? Okay, so if we have the same situation, I want to find the second derivative of w with respect to u. What should I do now? In that case, I should start, so you see, I should start with the derivative of w with respect to u, which I have, and then I want to take derivative of that with respect to u one more time. So I have partial w with respect to u, and I'm taking derivative of that with respect to u one more time. Okay, so I look at the partial derivative of w with respect to u, and I start taking the derivatives of that. So I have derivative with respect to u of 3x squared y plus y to the fourth times 2u plus partial with respect to u of x cubed plus 4y cubed x times 2v. Okay, now let's look at this function. This is the function of u. This is also a function of u because x and y are both a function of u. So I need to use product rule in here because I have two functions. So using product rule, I can write derivative of the first one. Let me just keep writing this. I'm not gonna calculate it right now. I'm gonna come back to it. So derivative of this one times that, 2u, plus derivative of this one with respect to u, which would be just 2 times this function, which is 3x squared y plus y to the fourth. Okay, so this is the first part. Now look at the second part. I have a big add sign in here. Now the second part, I still have product rule, but in this time I have like this. I'm gonna take derivative of the first one with respect to u of x cubed plus 4y to the 3 times x, and times the second one, which is 2v, plus derivative of the second one with respect to u. So derivative of v with respect to u would be 0 times that, it's 0. Let me graph this function now. So I have a w with respect to x and y, then I have uv in here, uv in here. So as you see, v is not a function of u. U and v are both independent variables. That's why derivative of 2v with respect to u would be 0. Now let me calculate these parts. Okay, so for that, look at this function. I have a function, I'm gonna call this one m. the function m, as you see, it's a function of x and y, and both x and y are functions of u and v, because x is u squared plus v squared, and y is 2u plus v. So okay, so for finding derivative of the function m with respect to u, I can go along this path, or I can go along this path, you see. So I have what? For this part, I can have derivative of m with respect to x, derivative of x with respect to u, plus derivative of m with respect to y, derivative of y with respect to u. You see? So now what is derivative of m with respect to x? Is just 6xy times derivative of x with respect to u. What was x actually? X was u squared plus v squared. Okay, so derivative of that with respect to u, it would be just 2u, plus derivative of m with respect to y, it's just 3x squared plus 4y cubed. Derivative of y with respect to u, which is just 2v. Perfect. So this terms in here would be just derivative of the function m with respect to u. Okay, now I don't have anything to calculate right here, but I have the same situation for this part. As a practice, I can call it n. So you see, n is a function of x and y, and both x and y's are functions of u and v. That's why to calculate derivative of m with respect to u, I can write derivative of n with respect to x partial u, plus derivative of x with respect to y partial u. Okay, so derivative of n with respect to x is 3x squared plus 4y cubed. Derivative of x with respect to u is just 2u, plus derivative of x with respect to y, it's 12y squared x. Derivative of y with respect to u is just 2v. Very good. I have all the terms that I need to calculating the second derivatives. Now I can just rewrite everything that I have. So partial derivative, the second partial derivative of w with respect to u is just these big terms in here, which would be 6xy 2u plus 3x squared plus 4y cubed 2v. This parenthesis times 2u. I didn't simplify anything. Then this part, which is just 6x squared y plus 2y fourth. Then plus, I have this term in here, which is what? Which is 3x squared plus 4y cubed times 2u plus 24 y squared xv. That term in here times everything together times 2v. Oops. 2v. Okay, this is the second partial derivatives.